Hello everyone. In this video, we are going to talk about wave optics. In the previous lectures, we saw what is ray optics. So in ray optics, we consider light as a straight line traveling from one place to another. So we used to consider light as a ray. So since light travels as a straight line, we can consider light as a wave like this, which hits on a lens, and then we see how it gets focused and forms an image. So this is a study where we consider light as rays. But in wave optics, we consider light as an electromagnetic wave because light is an electromagnetic wave. So when we consider light as an electromagnetic wave, we need to incorporate the wave nature of the light and understand the properties like wavelength, frequency and speed, how they change when light moves from one medium to another. So all this we will study in this chapter. So in this particular lecture, we are going to talk about Huygens principle, refraction and reflection of light from a plane surface, the Doppler effect. First, what is Huygens principle? So you have all seen this kind of ripples form in a pond where you throw a stone. So these kind of ripples that are formed here are the wavefronts. So what do we mean by a wavefront? Wavefront is the surface of constant phase. For example, in the waves, if you consider the points which are in the same phase from the center, and if you join all the points, then you get a surface like this. This is a wavefront. This wavefront can be there in 3 dimensions also. In this case, it is there only in the surface. But what if you imagine a source at the center and then the waves are spreading in all 3 dimensions and they will form a spherical wave. And similarly, plane waves also. If you consider the spherical wavefronts at a very far distance, the small region, they will look like plane waves. So what does Huygens principle say? Huygens principle gives an explanation about how wave spreads through the vacuum or medium. When there is a wavefront, let's assume this is a wavefront. Huygens principle says that each of these points in the wavefront acts as a source of light on its own. So for example, if there is a wavefront point here, this itself produces this kind of waves around it. So let's see an example here from F1, F2 to G1, G2. These are two different planes at a time, at two different times, t equal to 0 and t equal to tau. Let's see here the points A1, B1, C1 and D1, they themselves create so many wavefronts. And if you see, if you take the points with the same phase and then join them together, then you get another wavefront. This is how wave propagates in a three-dimensional way. That's why waves always spread, because every point in the wavefront acts as a source of wavefronts.